Good day everybody, we got an interesting question. We are expected to integral x times root of x 3 times x squared positive 1 times dx. So what I wish to do, I would like to take 3x squared positive 1 to be equal to some t squared and differentiate both sides. This is going to be 6 times x dx is equal to 2 times t dt. I need only x dx, so x dx is placed here, 2 t dt on the right, 6 is moved to the right, so this is going to be 1 over 3 times t dt. So I'm going to write it like this, t dt, and this is nothing but x dx. So therefore the original question can be rewritten like this: 3 times x squared positive 1 times x dx is equal to integral. In place of 3x squared positive 1, you substitute t squared. In place of x dx, you substitute t dt divided by 3. Move this 3 out, and this is going to be root of t squared is going to be t, and you got a t there, so t into t is t squared dt. You integrate this, you get t raised to the power of 3 divided by 3. There is already a 3 there, so this is going to be t raised to the power of 3 divided by 9, which can be rewritten as, now you have t squared is equal to this quantity, right? So therefore t is equal to root of 3x squared positive 1. So you have to take it back over here. So this is going to be root of 3x squared positive 1. This is raised to the power of 3 divided by 9. You can again rewrite this as 3x squared positive 1. This is a square root sign. That means this is raised to the power of 1 over 2. That is the exact meaning of this. And this is again raised to the power of 3. This is divided by 9. Now a raised to the power of m, which is again raised to the power of 1 over n, can be rewritten as a raised to the power of m over n. Okay. By this is nothing but 3x squared positive 1 raised to the power of 3 over 2. So this is also applicable if you have a raised to the power of 1 over n, which is raised to the power of m. You can rewrite this as a raised to the power of m over n. So that is how I have got this 3x squared positive 1 raised to the power of 3 over 2 divided by 9. You have to place this arbitrary constant c. If you do not place this arbitrary constant c, your solution will not fetch you complete marks. Okay, so having got that, let's go on to the next question.